Hello dear friends, today I will discuss Dirac delta function, or sometimes it is called unit impulse function. So now what is Dirac delta function or unit impulse function? So what does it mean? What do you mean by impulse? So impulse means, you can see here, the action of very large forces over a very short interval of time. What is the meaning of impulse? Action of very large forces over a very short interval of time. That means you can see these situations in the phenomena where impulsive nature occurs. For example, when a ball or tennis ball is hit, when a ship is hit by a high single wave. This is also an example. And when a system is given a blow by a hammer. So there are some examples where you can see the impulse, short impulse. Okay. So in mechanics, how we define an impulse of a force f of t over a time interval. So what is the time interval? Suppose it is a to a plus k. Suppose it is a to a plus k, and how it is defined in mechanics, it is the integral of f of t from a to a plus k, from a to a plus k. And we can note here, what is this k? K is a very small number. It's supposed to be tends to 0, and it is greater than 0, but it is tends to 0. It is very small. So that's why the interval is very small. So because we defined we have to take a large force over a very short interval of time, so interval is a to a plus k. So when k is very short, then this interval is very small, and in that interval we have to take a force which act for that interval. Okay, so to handle this type of situation, we can consider the function like this: fkt minus a by 1 by k if the t is in between a to a plus k, from a to a plus k, and 0 otherwise. Okay, so how it is, means why we will take here fkt minus a, because k is very small. For this, when k tends to 0, it is 1 by k, and a2, it's a very small interval of time, and otherwise it is 0. In other cases it will be 0, because we have to take the only for that interval, only for that short interval of time, this fkt minus a. So if we consider this function fkt minus a like this, then what is its impulse? By this definition, we can take this impulse is the integral, ik is the impulse, and this is equal to the integration from 0 to infinity fkt minus a, is not it? And if we break for this interval, if we break it 0 to a, suppose just break it 0 to a, then a to a plus k, then a plus k to infinity. So for this and this case, for these two cases, the value will be 0. The value will be 0. And only for this interval a to a plus k, the value is 1 by k. So put the value of fkt minus a as 1 by k. So 1 by k into dt, and limit is a to a plus k. And for other value, means other cases, it will be 0. So that's why if you integrate it, it will be 1 by k, and integration of dt is t only, and for upper limit minus lower limit, so a plus k minus a, and the value is a minus a cancel, so 1 by k into k, so the value is 1. So it is having unit impulse. It is having unit impulse. So that's why it is also called unit impulse function. And if we, that means this fkt minus a as k tends to 0 is denoted by and defined by your Dirac delta function, and it is denoted by delta t minus a as k tends to 0. You have to note this, k tends to 0, k greater than 0, but it is tends to 0. And it is denoted by delta t minus a, that is delta t minus a is equal to limit k tends to 0 fkt minus a. Okay, so limit of fkt minus a, so this is a limiting value, and as k tends to 0. And this delta t minus a is called what? Dirac delta function, or we can say unit impulse function. Sometimes it is called unit impulse function. Okay. So we got when we consider fkt minus a as 1 by k if a less than equal to t less than equal to a plus k and 0 otherwise. Okay, so when fkt minus a is 1 by k in this interval, and in other cases it is 0, then we define delta t minus a, that means as k tends to 0 means limit, what we defined, limit of fk t minus a is delta t minus a. So since k tends to 0, then k tends to 0 means it is approximately equal. So a less than equal to t less than equal to a, that means t equal to a. So when t equal to a, as k tends to 0, this value will be 1 by 0, that means infinity. So delta t minus a is equal to infinity if t equal to a and 0 otherwise. Okay, so we can define the Dirac delta function delta t minus a as infinity if t equal to a and 0 otherwise. Okay, and we got the impulse of this function fkt minus a is 1, because if I take like this, fkt minus a is 1 by k, and in the interval a to a plus k, and obviously this integral gives the area, this area is 1, so it is unit impulse, having unit impulse. So now what is our goal? The goal is to find Laplace transform of this Dirac delta function. So how to find Laplace transform of Dirac delta function so that we can use this in the problems involving short impulse. So therefore we will try to find this Laplace transform of this delta t minus a. So to find this, write this fkt minus a, what we have considered fkt minus a, and this take this fkt minus a, write this fkt minus a as means using unit step function. So in the previous lecture already I have told how to write a function using unit step function, and that means if it is just recall it, if the interval is a to t, then t to a plus k, then what we have to write? The value fkt minus a is equal to, value is 1 by k, so 1 by k whole into u of t minus a, u of t minus a minus u of t minus this, u of t minus a minus u of t minus a plus k. So therefore it is 1 by k whole into u means unit step function, so unit step function, so u of t minus a minus u of t minus a plus k, and 0 otherwise. So for the other values, other cases it is 0, so don't write this, only for this interval we write this fkt minus a using unit step function. So because we know that Laplace transform of unit step function, that is what? Laplace of ut minus a is what? E to the power minus as by s. Already we have discussed in the previous lectures. So therefore Laplace of, if we take Laplace on both sides, so Laplace of fkt minus a will be equal to 1 by k is constant, so 1 by k using linearity property of Laplace transform, we take Laplace of e to the power, means Laplace of ut minus a, so it is e to the power minus as by s according to this formula, and minus Laplace of ut minus a plus k, so in the place of a it is a plus k, so it is e to the power minus a plus k into s divided by s. In place of a it is a plus k, so in place of a just write a plus k. So e to the power minus a plus k into s whole divided by s. Right. So what is the value? E to the power minus as. Again here it is power minus as. Here is also e to the power minus a. So you can take it common. So e to the power minus as whole into 1 minus e to the power minus ks divided by ks. If we multiply k with the both the terms, so therefore we will get 1 means e to the power minus a is common. So 1 minus e to the power minus ks whole divided by ks. Right. So this is Laplace transform of fkt minus a. But we have to find Laplace transform of delta t minus a. And we know that it is the limiting value of fkt minus a as k tends to 0. So that's why taking as k tends to 0. So therefore your left hand side means limit k tends to 0, this value will be delta t minus a. So therefore this is Laplace transform of delta t minus a in the left hand side, and the right hand side it will be limit k tends to 0 on the right hand side. E to the power minus a is 1 minus e to the power minus ks by ks. Clear? So as k tends to 0, so there is no effect on e to the power minus as, so take it out, e to the power minus as, then limit k tends to 0, 1 minus e to the power minus ks by ks. So for this term, this limit will affect this term only. So now if we put k directly as tends to 0, so it will be what? 1 minus e to the power 0. E to the power 0 means 1, so 1 minus 0, 0, again divided by 0. So it is 0 by 0. So as we know that to find the limit of this term when it is 0 by 0 form, so what we have to use? It is L'Hospital rule. We have to use what? L'Hospital rule. L'Hospital rule. So what is L'Hospital rule? We know that we have to differentiate numerator and denominator separately. We have to differentiate numerator and denominator separately. As k tends to 0 means with respect to k, we have to differentiate numerator and denominator separately. So therefore, limit k tends to 0, e to the power minus a is unaltered, and limit k tends to 0, so derivative of this differentiation of numerator. So for 1 it is 0, then minus e to the power minus ks, e to the power minus ks into minus s, because we have to differentiate with respect to k. So therefore s is constant, so minus s, so minus minus plus, so s into e to the power minus ks. Again with respect to k, we have to differentiate denominator, so therefore it is only s. So for k it is 1 and s is constant, so s cancel, so only we got e to the power minus ks. Now if you put k tends to 0, it will be e to the power 0, e to the power 0, is not it? So e to the power 0 means 1, so e to the power minus s into 1, so therefore the value is e to the power minus s. So what we got? Laplace of delta t minus a is equal to e to the power minus as. Okay, so this is the Laplace transform of Dirac delta function, and that is e to the power minus as. Okay, so we can note here that when a is 0 here, suppose a is 0, if I take a equal to 0 here, then what we got here? Laplace of delta t is equal to e to the power a is 0, so e to the power 0 means 1. So Laplace of delta t is equal to 1, or you can write this as your delta t is equal to Laplace inverse of 1. So we can note here Laplace inverse of 1. We know that Laplace of 1 is 1 by s, but what is Laplace inverse of 1? We can use this delta t. So Laplace inverse of 1 is delta t. So it's a very interesting result. So Laplace inverse of 1 is delta t. We can use in some problems. And here is also, we can take, if you take Laplace inverse on both sides in this formula, then what we will get? Delta t minus a is equal to Laplace inverse of e to the power minus s. So where we will need Laplace inverse of e to the power minus s, just write delta t minus a. Okay, so these are about Dirac delta function, and suppose we give an example also. We can also give an example. Suppose we have to find Laplace inverse of, suppose, just see here, Laplace inverse of Laplace inverse of uh, s, suppose we take s square divided by a square plus 4. Laplace inverse of a square divided by a square plus 4. So how to calculate this? Directly you can take like this, Laplace inverse of a square plus 4 minus 4 divided by a square plus 4. Just add 4 and subtract 4 here. And we can separate like this, Laplace inverse of a square plus 4 divided by a square plus 4 minus 4 divided by a square plus 4. Now, what is the result? What is the result here? Laplace, because it is a linear operation, so Laplace inverse of a square plus 4 or by a square plus 4, so this is 1. So Laplace inverse of 1 minus Laplace inverse of 4 divided by a square plus 4. So that is equal to Laplace inverse of 1. So what is the value of Laplace inverse of 1 here? Delta t. We got delta t. So delta t is minus Laplace inverse of this. Already we know that this is 4 divided by square plus 4 means it will be, we can write this 4 as 2 into 2. So 2 divided by a square plus 4. A square plus 4 means it is 2 square. So 2 and 2 by a square plus 2 square. So what is this? Sine 2t. Sine 2t. Okay, 2 into sine 2t. So this is the result. So in this way we can use this Dirac delta function to find out the Laplace inverse or Laplace transform of some function. Okay, so in the next lecture again we will discuss some problems involving this short impulse function, Dirac delta function, right? Again we will meet in the next class, in the next lecture. Thank you all.